Okay, it's 3 o'clock. We'll get started, okay? So today we are going to get to the last chapter for this C-level plus and C-level plus problem solving with algorithm and data structure. This DSA course, we come to the last chapter. But in fact, this chapter is the most important part. It is actually containing the graph. And then this one, we may take several weeks to work on it. Breakfast searching, night theory problem, depth first problem, strongly connected component problem, and then primes spanning tree algorithm, minimum cut problem, maximum cut problem. Okay, there are tons of problems, very useful problem in here, okay? So it's really a totally different class compared to previous one. Previous one actually kind of not that important. And this one actually, if you look at the user code, chapter one, we say chapter one. Chapter one is basically on searching problem, binary problem, those kind of different things. These are actually for bronze to silver or early silver, okay? This is chapter one. Chapter two, actually, get started with graph. So actually, this graph theory actually is the beginning part of silver to gold, okay, in user code. So it's very important. But you know, when we started C-level plus, we cannot jump directly to here. We have to actually work on the language first. So maybe next year I'm going to change my curriculum a little bit. It's actually take too long to reach this point. Anyway. Okay, so basically today we are going to start a graph theory, and last time we talked about some basic part for graph. So graph is a concept. It actually is an abstract data type. Okay, and it contains of basically two things: vertex, or sometimes we call it node, and edge. Edge is relationship from one node to the other. That's actually called edge. And edge can be this directional and one directional or bidirectional or no direction. Okay, so actually those are the basic concept. And then you can show the vertex and edge. Edge is sometimes a pair, okay. And vertex is some number, okay. That's actually like that. Okay, so in the past, say, let's see, here are example of the graphs. Given the set of computer and wire running between pairs of computer, what is the minimum number of machine that cause two given machine to be unable to communicate? Okay, and given the vertex of the computer, the edge of a wire between the computer. So you actually have, let's assume that you do have A, B, C, D. Let's assume that you have something like this, okay, and you have E. Okay, let's assume this is the graph. So what is the minimum number of machine that whose crash cause two given machine to be unable to communicate? Two given machine will not crash. So two given machine, maybe they give you A and C, maybe E and C, okay? So let's assume that actually take a look on A and C. Then you actually would like to see A and C, and you say minimum machine that actually is to find a minimum cut. Okay, this is minimum cut, right? These are the minimum cut between E and C, and this different cut is the minimum number of cut that actually would disconnect C and E. So C and E actually the minimum cut is this one. This one, if we cut, then C and E will be broken. So this is an example of the graph, but this one is called mean cut problem. Okay. Helen, is okay?
Yeah.
The mean cut problem. And then there are the writing preference problem, nice move problem, okay, over several problem, okay. So these are different problem and edge list, okay. So we'll come to the problem later. So this one, if you study the graph, you study the theory itself, there's not a lot of things that you can learn, but this one, we do need to study a lot of the examples, okay? Actually, the key point is in the examples. Just like you teach math or algebra, that's pretty easy. But when we come to the problem for the linear algebra or all kind of the Boolean algebra, the algebra problem can be very tough, okay? So let's actually go back to the website. Not this one. For the class. So we actually last time talked about a basic idea. So today let's actually implement a example. Let's get started with the adjacent list first. Okay, adjacent list. So basically, when you see graph, there are two ways you can implement it. You have the idea is like this. You have A, B, C, right? But your implementation, you can have A node neighbor is B, C. B node actually neighbor is actually what? Is actually A and C. C node neighbor is B and A. Okay, so this is the edges that you store, neighboring edges that you store in the graph. Okay, so vertex you have A, B, C, and then the neighboring node, A has BC, B has AC, C has BA. So if you store the neighbors in a list, then this is a graph using the so-called adjacent list. Okay, adjacent list to do it. So now let's actually look at the implementation. I'm not going to copy from anywhere. I'm going to create it by myself. But the first thing you would like to create would be, let's call it node. Okay. So for data structure linked list, for tree, for graph, the same, first thing you need to have a node. Okay, I'm not going to copy from anywhere. I would like to get started from here. Okay, so here we would have a class node. Let's use this, okay? And finish curly braces. Okay, and this one would have private part and the public part. Private part has have integer as the key. Let's use string as value. Okay. Okay, so we get started with this. Okay, we have the private part, we have base public part, and private part with key and value. Okay. This is one node. There's no P. Okay, I'm sorry. There's no P. I have a typo. So public parts actually get started with the node constructor, no argument. Okay, this one we would have T equals 0. Okay. Value equals empty string. Okay. Okay, and we have a node value. And you may have integer k, okay, and the string values of v, okay, values of v, and then you actually have t equals k, okay, and also value equals v. Okay, so this one is a constructor, and you may also have a constructor that actually use node alias n, okay, and then this one you have the t equals n dot t, okay, and your value equals n dot value. Okay, you copy from another node. Okay, so these are typical constructor and okay, something like that. And then you have the void operator equal sign. This one is a node. Is a copy constructor. Okay, copy constructor. So you will be equals to n dot p, the same one. Okay, and then value equal n dot value. Okay, this one's the same. Copy constructor and this one is the same. Okay, usually it's the same. And then let's see. And that's actually, we still need to have some public function. Let me copy. Okay, this part I actually need to have look at something else. So let me do copy. Okay, let's go to the C++ 2 to copy from some of the linked list or string classes. So let's try chapter 14. Okay, this complex number. Let me actually get to the header file. Let me see header file. Okay, this complex number is actually open with not Pythagore class. Okay. What I want to have is the typical function. Okay, the toString function is operator function. Okay. So let's actually do this. Get these functions. Okay. Oh no, from here. Let's get this function. Okay, it's different function. Let me copy. Okay. Copy the complex class 1. Okay, so here I think I make some mistake. This one should not return. Okay, this one should not be just this easy. So this one should be returning node. Okay. And then these two actually okay, but you should also return. Okay, the body of this. Okay. Okay, this one, okay, let's take out. Next one is toString function. Okay, so toString function is converting the object to a string format. So this one is a friendship function, string to string. Okay, you have a constant type and then node alias n. Okay, and then you go into, okay, you need this string. So this one you need SS string, okay, string. And then you actually, let's copy this one directly to there. So you create a string that's called stm, and then you put your t dash value, okay. But before you key a value, let's actually do put a double greater sign before it, and then do closing agree after it, and you return the C string type from the string, okay, and then that's equal to string function. So this one done, okay, we don't need it, let's cut it. I'm sorry, I actually hit the wrong button. Sorry, I hit the wrong button. So this one, let's take it out. And then next one, we have the operator less than. That's actually is the conversion of the string. So right here, you are going to get this one to no type, okay. And then you are going to convert the string to here, okay, that's no problem, okay. This one, input part, you actually get the object. So you input to the and then it turns into value. So you key into value, key and value, and you return the object. So far, okay.
Yeah.
This one is to create a node, okay? Create a node and then make it to be able to string and also have these. Okay, and there's a key and value. So we just create a node, and this node can be used for a vector, a linked list, a tree, a trie. Okay, we talked about trie before, and also can be used for graph. Okay, can be used for graph. So building a node for many different kind of data structure is very important. We didn't do it because last time the data structure is easier. So let's actually get this one, and then let's do create a tester. So tester testing the node, the CDB. Okay, so our main function now, just to test the node, this one. So let's do include IO string. Okay, include string. Okay, include this one called node.h. Okay, and then using namespace std. Okay, integer name for return 0. Okay, this one is make it worse so far. Okay, so let's actually do this. Okay, let's do this. So okay, let's create a node. Okay. Okay, 5-element node. Okay, let's call it unleashed. Okay, so for integer I equal 0, I less than 5. I plus plus, okay, and then you do C out, enter key value pairs. Okay. And then you do in to your unleashed I. Okay. After you finish that, you do C out. Enter. Okay. And then for integer I equals 0, I less than 5, I increase C out. Node unleashed I enter. Okay. Okay. Is that okay?
Yeah.
So we actually create, okay, the second one should be string, but I use number as it's okay. But we do create a key and value, key and value, key and value, okay? And the node can be printed as key and value. So this is testing of the node, no problem. Now this one, we are going to create a so-called graph. So graph, you can put it into a class, or you don't would like to have a class, up to you, okay? So you can put it into the class. You can also put it as a non-class format. But now you need to actually create a vertex list and also a neighboring things. Okay. So let's see here. You should let's actually use a class. Okay, a class. Let's put them into a class. Okay, let's put them into a class. So here let's create it. There's something called graph. Let's see this one class. Let's call it. Give it a name. Okay. This one is called. Let's see. Okay, just call it book graph. Okay, let's create a class called book graph. The H. Okay. Okay. I don't have the name for the graph, but so I use the book graph. Okay. So this one, let's create a class. Let's call book graph. So book graph is one kind of graph. So we create a class for it. Okay. So this graph, you should have a. Okay, you should include vector, okay, and using name space vector, namespace std. So we want to use a vector. We want to use a node, many node. So we actually will put a here let's actually do this, let's do type define. It's called vector of node. Okay, so this one you also need to include the node package. Okay, so you have the vector node. This one we call it vertex. Okay, multiple. We use a vertex. Okay, so you have a vertex. V. Okay, it's data field that's called vectors. So you have many nodes that's actually called V. Okay, and then you also have type define vector. This one is using the pointer to node. See, you have a vector of pointer to node. Yeah. So this one, let's call it. I'm sorry, this one call it edges. It's a pointer to node. Okay, no problem. So which is we okay. Something wrong. Let's see. Error type standard container or pointer to. Okay, let's see. Let's do type define pointer to node. Call it node PTR. Can you do that? No. Oh, I'm sorry. It should be node and then start here. I'm sorry. Forget it. Okay, it's a pointer to node. Is the start is after not before. Okay, so this one is called edges, but it's also a vector. So basically, you have many vertex and you have many edges. Okay, so your graph do have a let's see, this one is called it private part. Okay, you have these different vertices and different edges. And then you have fabric. Okay. So that's actually create. Okay, let's see. Create book graph. Constructed no argument. Okay. Let's actually get started for that, and then we can actually do void. Okay, at node. Okay, in node. So you will have a node and then alias n. Okay, and you are going to add a node to the vector. So your vertex, your v. Okay, your v would do push back the n, okay, it's no problem. So you add one node to it, okay, and then you do void at edge, okay. Then you have your node, okay, from and node two, okay. Okay, let's don't call it from and to, let's call it A and B two node. Okay, and then this one your age that okay. Your age is actually is no, actually your age is wrong. Your age is should be a vector or node. Okay, I'm sorry. So your vector ages is not at least okay. Your actually this one's wrong. You have so many nodes. Those are actually vertex. Your age is actually is a vector, or each one of the vectors should be a list as well. Okay. So your graph should have a vector of ages. Okay. Actually code E. Okay. And then so when you actually add a node, then your age should create a new element. Okay. So your age is a vector of the nodes. Okay. So you do age is Vx. Okay, you create a Vx and then you do age at add actually push back Vx. Okay, something like that. Okay. You need to create edges and then put it into there. So whenever you create a node, you should also create its edges. Okay. Now you want to create an edge, and then you also want to put a node edge to there. So you are going to do right here. Okay, so right here you are going to do integer. Okay, from t. Okay, the key. Okay, let's do let's call it a key. A key equals a dot t. Okay. A is a node. What's wrong with a dot key? Declare in 9.6. Let's see. Oh, it's a private data. Okay, I'm sorry. So this one is not okay to do key. It's actually a different class. So right here we need to add actually integer get key. Okay, return key. String get value. Okay, let's do this. Okay, actually get value, and then this one is return value. Okay, something like that. Okay, so you have get key and this get value. Okay, something like that. Go back to your graph. So right here it should be this one for get key function. Okay, the key function, you get a key from A, okay. And then you also have integer b key equals b dot get key. Okay, so then you have the so-called edges, many different edges. Okay. Let's assume that A and B both in the graph already. Okay, if it's not in the graph, then you cannot. Okay, so let's see. Actually, okay, let's actually create a function. Okay, here let's create a function. Let's call it Boolean. Okay, in graph. So you have a node. Okay, and you let it check if it's in the graph or not. Okay. So actually do get a key A, okay, it actually do know that get key, okay. And then for actually every node X from your V, okay, from your V, and then okay, and then is expected key equals to A, okay. Then you got it, right? You got it. So you will return true. That means that you are in a graph. Okay. If you search for every key and you do not get it, then you suppose you do not have that node in the graph. Okay. Okay. So right here, you need to check the A key that in graph or okay. So if A key not in graph, okay, I'm sorry, it should be A key not in graph or in graph. B key, okay. So if A key not in graph or B key not in graph, then you will return. You do nothing. Okay, you cannot check. Let's see. Actually, I'm sorry. You should put in A and B. Okay. To check if the both are in graph or not. If one of them not in graph, then you cannot add the edge. Okay. So if both in graph, then you would do this. You would do okay. You push in. You will actually push in one of the edge to the graph. Okay. So you have the edges. Okay. You have the edge. You have the so-called E. Okay. E is a multiple edge. Okay. So let's see. You actually do. You have the A key and the B key. Okay. So you do. Okay. Your type is edges. Okay. A key value. This one should be E, not edges. E A key. Okay. Let's see. You have a key and a value. No, This one is not. Okay, this one actually, this is wrong. This is wrong. You need to get an index. Okay. Okay, here you should have a function. Let's call it integer index. Okay, you try to look at your node various n's index in the graph. Okay, so you will get a key and then okay, you get a key from the n. Okay, and then this one you should do for integer I equal 0, I less than the so-called beta size I increase. Okay, and if these i's value that the t equals k, you will return I, otherwise you will return -1. Okay, so this one will get the index of a node. Okay, the index of the node. So here you are going to do integer I equals integer idx equals to index of your node. Okay, you get a node, your a node index, and then your edges index will push back edges of B taking the neighbor to it. Okay, and then your index B. Let's put the A there because you have A and B. And then index B will be equal to index B. So your these index B push back the edges of A. So for this one, you actually push in a node to A's edges, pushing a B to A's edges, pushing A to B's edges. Okay? Any questions so far? Then this one, let's do toString function. So we got a graph. Let's actually do toString function for the graph. Okay, let's actually do the so-called toString function. So graph you can convert it to string as well. So let's put the toString function right here. Okay, you created the string and you are going to do this. You are going to do string, okay, and then you do vertex, okay. So right here is non-node. It should give a good graph. L is G, okay, you put graph G. And you do for integer I equals 0, I less than G dot E, okay, the size. I plus plus. You go to the every vertex. So you do this, okay, you do STM and then G dot V I enter. theta vi is a node. So here let's actually push to space. And then you print out the vertex. Okay. No, let's don't do it. Okay, let's actually do. No, let's don't do it this way. Let's actually let's do that big key. Okay, that's value. Let's don't do it. So here, that's actually if we do no, let's do this. If I equals 0, we do this. Else, we do stn comma, and then GW I dot it. Okay, at the end you do stn, but giving the handle to it. So this one you are going over every of the G long GWI G, how comes G actually? G is a graph. Graph have vertex. Wait, how come this one is wrong? The object type qualifier not compatible with the member function big key. So right here, with two string, we have a GG is a book graph type. And each book graph type, G's VI. G's VI has, that's correct. But G's is a vector of the nodes. Like actually don't do the get key, just directly put the, let's don't do get key, okay? That's actually each one of the VI, that's actually just actually let's just print out a node, okay? So this one are different vertex. And then let's do stm, okay? And then edges, okay? Then you do for integer I equals 0, I less than, okay, G dot E dot size equal to every edges I increase, okay? And then you do this, you do stm node, and then you do these I that get key. Key that vi that get key. How come G that vi cannot use get key? Okay, let me do this. Let me actually have create a node x equals zeta vi. Okay. Zeta vi. I'm sorry, let me delete this part. Class node has no copy constructor. Let's do this. I'm sorry. Here, this one. Class node has suitable copy constructor. Okay, let's create alias. Let's take out a constant. Okay, so this one I have the alias, and then this node, I will get key for it. Okay, and then I'm going to do, this should be like this, this one should be like this, space. And then here should be have this. And then here should be, okay, like that. Okay, so we get one node, and then we print the node number. And then we would like to list down all the ages. So for integer j equals 0, okay, and then j less than is I, okay, that's size j increase. You have g dot e go to every ages, you get the node, okay, and then you go to the nodes every edges. That's called j, okay, and then you are going to do node alias y equals g okay, you are going to get the node, so you are going to get these i's j element party will be assigned to y, okay, and then if j equals 0, you are going to do stm, okay, y dot get key else you do stm comma y dot get key. Okay, as you can see, to construct a graph actually take a lot of time. So far we are able to traverse to get the vertex and the edges. Okay, one version for it. So here, this one, we have a graph, we have a vertex, we have the vector of the edges. We create a graph, we add node, and then we check if it's in graph. we consider look at the index, and then we will add edges. Okay. Now this one actually so far okay. So let's assume that we have a 1, 2, 3. Let's just control this graph, and you have A, B, C as the string. Okay. Let's control this graph. So here, let's actually do test graph.cpp. Okay. Okay, created everything, and you also need to do improve. Okay, improve graph.h. IO stream missing an A. Okay, this one improve. Okay, now we are going to create such a graph. So we are going to create node A. Okay, and then using 1 and string A. Okay, this one create a node A, and node B. Okay, create 2 and B node. So you also need to have a node. So let's do improve node.h. C. Okay, and then 3 and C. Hey, what's wrong? How come here it's actually not working? No constructor. Go to node. No constructor that match key integer and value. Yeah. So how comes that? How comes that it say that there's no constructor that would match it? We do have an integer and then constant a capital 2. Okay. So that actually is from the constant capital 2. We are using string, but it's actually constant capital 2. So let's try this one. Let's actually try. Okay, open. Let's try this. So here you want a string type. Let's do string x A. Okay. A. Okay. So here let me put XA. Is that okay? Okay. Okay. This will work. So it need require a string. So let's do also XB with B. Okay. Let's call it C or C. So here we have XA, XB, XC. Okay, so we actually build up the 3 node. Okay, and then we will create a graph. A full graph. this one called GG, okay, GG. And GG that, let's do what? GG that we would put, we create it, so a node, okay? So a node, we are going to do GG that a node of a GG that a node of B GG that a node of C. Okay, so we add 3 nodes to there, and then we do GG that at H. And then you need to have a 2 node, okay? So at H of A and B, okay, GG that at H, B and C, okay, and then GG that at H, A and C, okay. Okay, so this one we complete all of the building for the graph and node and edge. And then we are going to do C out, okay, GG dot toString. And okay, we are going to create GG toString. Wait, what? Oh, that's actually a friendly function. I'm sorry. So it actually is toString of GG, not GG dot toString. It's actually a friendly function. Okay, so good enough. This one actually is no input. No input, we can directly use run code to run it, okay? Something wrong. Something wrong, okay? Something wrong. Let's see what's wrong. So it actually happened instantiation, the node. Okay, before we test the graph, let's actually stop, okay? We actually test the graph, but before we test the graph, we have a node ABC. So that's up to here, okay? Up to here, let's test if the ABC work. Okay, up to here. And then we do C out A and C out B and C out C and okay, so it's actually printing ABC, okay? So let's save. Let me do it one more time, okay? Wrong code. So compiler didn't pass, okay, didn't pass. Okay, let me do this. Let me actually do not include a good graph for the time being. I just want to test the code. So save and then run code. So this one only ABC it work, okay? So then we include a book graph. So book graph actually is something wrong, okay? So this part is okay. ABC, we can trust it. So book graph.h, there is something wrong, okay? Let me do compiler one more time. the version of the whatever rounding is not compatible. Let me actually do using terminal. And G double plus test graph. Let's do test graph CBP HO test graph. Okay, so this one is wrong. Let me look at the test graph. So include that, and then right here, instantiation of the new allocation with that, and then request static void allocation, whatever. Actually happen when you do pushback n, it creates trouble. Here is an instantiation argument. Node this actually it creates trouble. Okay, let's look at that node and then this node. And then there's an alias n. That one creates trouble when you do copy constructor. It did not create the right one. Okay, let me go back to test node. Okay. Test node. So we do have, that's actually using the test node. So right here, let's create a different one, right? Let's actually do with. So the node constructor has some problem. Let me copy this one. Let me create another one called test node number 2 CPP. Okay. Put the test node right here. I'm going to delete everything here. So I'm going to actually from test book graph, copy creation of this ABC, okay, and then put it into the test node 2. Okay, so I'm going to create a node D using A to create it. And then I'm going to see my D. And then enter, okay? So this one, D is actually from A. So let's see if this constructor work or not. Okay, so actually this constructor, it work. This one actually work. Then let's go back to test graph. So right here, how come the test, this one doesn't work? Let me see. So you have these, you have a node. You have a n, you come in with n, you push back n. Okay, let's see. Let's don't check this different one because let's actually comment them out. Okay, the in graph and the to string, let's actually comment this whole thing out. We will test it later. So for the timing, let's actually just test the so-called at age. Okay, add node. Let's just add node. So let's do test graph. So right here, let's do graph. And then let's do only n nodes. Okay. 8 different nodes. So let's go up to here. Okay. So this GG so far, let's just test the 8 node part. So let's just save. And test graph. This part is also save. So up to here, let's run it. Okay, it already has a red error. So the add node actually failed. Okay. So this add node actually failed. Let's see. Pushback N doesn't work. Pushback N doesn't work. So let me go to this test graph. So here, let's actually take out this alias. So when you do add node, okay, let me don't have an alias. Let's see. This one, the graph with add node. Wrong, it still wrong. Let me see. Let me commit it out, okay? So let's actually do this. Let's do GG dot. Okay, let's see. This actually a node already failed. Require from here. Constant node discard for the fire. Okay, let me try this. Okay, here let me actually put this over. Let's put a constant there. We are not going to change anything. Okay, so let's put a constant node this. And then you will push back the N to the V. And then you create a new age list. That should be fine. Save. Let me actually do test graph one more time. Let's run it. Okay, let me save one more time and run it. It still has an error. Let's see. Instantiation. Pushback. It's still on the pushback. Let me see, something wrong. It's still on the pushback. Go back to your graph. U graph is a vertex. Vertex is vector of the nodes. It actually is a vertex of nodes. And then when you get the node, you actually push back it actually doesn't work. Okay, let me try this. Okay, let me try to use a node X equal using the N to create a node X. And let's push in X instead of pushing N. How come it's wrong? You have a node N. Let's take out a constant. Let's look. Okay, it actually works in this way. Let's save. Okay. And then let's run this test graph, see if it's still working. Let me save. Let me run one more time. Okay, let me get out of here. Okay, I'm sorry. Let me get out of the environment. This visual shield double plus, I'm not sure. Let me do actually do CD. Okay, I'm here. Let's do G double plus test graph, CDB dash O test graph. It do create a lot of error. So initial argument, no, the alias, that's wrong. Okay, let me check some other, actually the adder is wrong. Let me take a look on other design. Let's go to the complex number. Chapter 14. Okay, let me take a look on this complex class. So complex class, right here, you have a complex alias T, that's actually fine, and you do P the real, this actually is copy, okay. Let me check the node. So this one is go back to node. Node you have let me change it to T, see if T okay. So T the key and T the value. So we have a node type. So this one is also put T type there. The copy constructor itself, I think there's no problem. But when we come to graph, you push back V is vector of the nodes. And we push back a node that actually create trouble. So that's actually right here. Try to use include, okay, vector. Let me test it, okay, right here. So here, let's assume that we do have a vector of node, V, okay. And then V that push back V, okay, let's assume that. We have a vector of node V, and then we push back the V into there. Let's actually see if this one work or not. This one doesn't work. This one doesn't work. Okay, let me try. E double plus this node 2, let's see if it is O, this node 2. It doesn't work. We create a vector of the node V, and then we push back a node into the vector. It doesn't work. Okay. So here, let me see. Okay, let me see. C double plus vector of a custom object. So we have a person that's a string and edge, okay? Constant, whatever, okay? So we create a vector and vector of person. When you add element, you have to use pushback person. You have to push back person. You cannot push back a node. Let me see. So here, if we don't push back D, let's push back node. One and the XA, let's see if this one work, okay? It doesn't work. See. No. So let me see. Let me actually do This one doesn't work. Vector of object from cluster class. Let me see. So this one actually is a problem. Okay, so look at this one, create vector of class object. Let me see. So here we do have student. Okay, student. And then there's a vector of student. So this one student is the getter. Okay, I think this getter is to get the data. And then it got pushed back. So let's actually try this one, okay? Let's actually try this one. Okay, try this one. Let's copy. This one is called it student CDP, okay? So it's actually related to the problem with the vector. So this one, we do have, I copy from internet. So there's a random integer function, random string function, there's a student, there's a row age mark, and there's a getter function for student that would actually get a random number. And then there's a display function. So we create a random student vector of V, and then we actually get every number, and then we push back the S to the vector, and we display it. Okay, so S is a variable. S every time it actually get different value and got pushed back. So this one is actually a vector of students. Let's run this one. Okay, it worked. It worked for this way. So this one has a student of vector of student, and then the student variable, you actually, this function, actually you have student, and student has this different value. There's no constructor actually, but you will get the value to it. Okay, let me go back to my test, this one. So here, if I do push back A, let me see. And then let's do this, let's do for integer I equal 0, I less than the size, I increase. And let's do C out. this i's value. Enter. Okay. So let's see. Let me make this one. This one had trouble. What is the difference? How comes my node cannot be done, but the student can be done? Okay, this is student actually is okay. Student, they had a number, they had a getter, and then they push back student. Student don't have the constructor. Student don't have the constructor. For some reason, student doesn't have the constructor. Very strange. So let me try my node, okay? My node, let me actually try a different way to create. Go back to my node. That's basically okay. Let's do not use the constructor at all. Okay, let's don't use constructor at all. I think the constructor creates trouble. So let's don't create use a constructor. So here let's do void set. Okay, set function. So let's have the integer k and the string s, and then your t will be equal to k, and then value equals s. Okay. Let's use this, and then let's go back to my node number 2. So right here, let's don't create this. Let's actually do create node A, node B, and node C, and then A that's set 1, and A, B that set 2, and B, C that set 3, and C, okay. So let's don't do this one. Don't do D. Okay, don't do D. And then we have vector of the nodes. And we will push A into there. Let's push A, B, C into there. Actually, no. Oh, it worked. So very strange that if I remove the constructor, it worked. Okay, learn something. Okay, this is very bizarre. I don't know what's going on, but that's the problem. Okay, so here we do this. Can this still be working? Oh no, this one you cannot run this one because it take input. So let's actually stop it. Let's do code that. So this one, let's use the terminal. And here the G double plus is node, the CDP, the node is node. The test node. 1A, 2B, 3C, 4D, 5F. Okay, so this one still working. So test node number 1, number 2 also work. Now let's go back to my graph. Okay, let's actually go to my test graph. So this test graph will now be working. Let me actually use test node number 2. So this is the right way to create it. We don't need that. Let's see, this one we don't need that. Let's delete it. Let's actually copy this different node with test graph. Okay, so put it right here. This one's test graph. So we create the different node. So we kind of test it up to here. Let's actually do file run code. Oh, it worked. So this one working. Let's test one more line to add the edges to there. Let's go to the graph. Let me turn on this different function for it. Okay. Let's do save. Let's go to test graph. No problem. Okay, let's actually go test the graph to string. Okay. So 18H and 18 node now okay. And let's run it. Okay. So it worked. Is that okay? It goes through the whole graph for all of the vertices, and each vertex is a neighbors. Okay. So the vertex neighbor, we should actually also change line. Let's go to the test, go to the graph. So here we will finish everyone. So right here, you should do STM endo. Okay. One more. Okay, go to test graph. Wrong. This node should again, it should actually change line as well. So right here, this one should add an endo here as well. Go back to test graph. Okay, so it worked now. Is that okay?
Yeah.
One thing that I bumped into today is very, very interesting. Is that student, okay? This one, from time to time, we may go into this kind of trouble. So the student class, it doesn't have the constructor. So this kind of class, when you add it into the vector using pushback, it will work. But if your student has a constructor, say student something, and then you actually use a student constructor, pushback will not work. Why, I don't know, okay? Why, I actually don't know. But today we actually got the bump over here, okay? So we slow down. But anyway, today we finished the building of the, okay, so today we actually finished what? We finished the so-called building a graph using the adjacent list. adjacency list, okay? So next time we will work on the adjacent matrix, but this time we work on the adjacent list. So I would like to show you how to build it from the scratch. So this time we actually take more time in building it. And we do bump into the vector problem, okay? So remember the vector, when you use the custom vector point, vector, whatever, that point operator, don't use the constructor, okay? You actually use the set function to set data later, okay? Any question? No question? No question, that's it for the day, okay? Sorry for the delay. See you next time, okay? Bye-bye.
Bye. Thank you.